What I'm going to start with here is a sign up sheet, basically. Remember, on Monday, you have the opportunity to make up one of your 3 exams. So what I need you to do is put your name printed, not in cursive, make it legible so I know who you are. And then next to it, put what exam you intend to make up. I need to have this. If you show up on Monday and your name's not on here, you can't redo the test. All right? Clear? All right. So please do that. I'll pass it around. This will give me an idea of how many of each exam I need to have ready. And remember, on Monday, if you're happy with your exam grades, you don't want to redo anything, then you have that day off. Also, though, I said that if you do redo an exam and the grade is worse than the one you had initially, that's what you have to go with. Okay, so whatever you do on Monday will replace your other exam regardless of its grade. Okay? All right, any questions over homework? We were doing long division, right? No questions? Sure. Okay. All right. Well, if there's no questions, then we'll cover our last topic for the semester, which is called synthetic division. Now, synthetic division, the word synthetic usually means what? Like, if you have like a synthetic oil or like a fake or something like that, or man-made, something like that. I've never really researched why they call this synthetic division. I might look into that, but it's kind of bad terminology because it makes it seem like this is fake or that this is somehow made up. But it's just it's a shorter way of doing division that we were doing before, but you can only use it in one scenario. So let me try and remind you from last class the types of things that we were doing. Okay, we were doing problems like this one. Here we had a trinomial, right? Divided by a binomial. What's the highest power down here on the bottom? What's the highest power or the degree of this polynomial? 2, right? Because the highest power of x is 2. Just keep that in mind, all right? Let's go to a different problem. Here, look at this one. We had a trinomial divided by a binomial. What's the degree of the bottom here? What's the highest power of x? What's the power right here? A 1, right? So this is, you're dividing by a binomial that has degree 1. Yes? See, is that all I had? I thought I did more examples than that. Maybe I have some on the previous day. Yeah, dividing. No, that was monomials. Okay, so I only had those 2? No, I had to have more than that, didn't I? Okay, well, this one's a little different. How about this one? I'm doing a binomial divided by a binomial. What's the degree of the binomial on the bottom? 2, right? Degree 2. So this is important because with synthetic division, you can only use this if you have a polynomial divided by something that looks like this, x uh, plus C, where C is some number. So the key here is that the denominator must be a binomial. Okay, that must be a binomial, and it also has to be degree 1. Now, you may be sitting there going, well, why would I want to learn this method if it only works in this case? Right? I mean, long division worked all the time. Why learn this? Well, there's really kind of two reasons. First is that it's fast. Once you get good at it, it's really quick, and so long division we saw can be kind of tedious. This one will go really fast as soon as you get it down. The next thing is that this is used later in college algebra to be able to solve problems, and so we use synthetic division on it. And what happens in college algebra is that we're always dividing by something like this, so it works out nice. So it's a good tool to have in our toolbox. Okay, so the best way to explain synthetic division isn't to give you steps, it's just to show you, and then you kind of just catch on to it, all right? Who else needs to sign in for if you're going to retake an exam? Anybody else? When are we retaking it? Monday. Were you here last time?
Yes, I was.
Okay. Yeah, we're going to retake it Monday, but today you were supposed to decide what exam you were going to retake. You can talk to me after class if you want. Okay, so let's go with our first example. And why don't we just take that example that we did last class that had the binomial in it. Where was it? Nope, not that one. This one right here. Does that one look like we could use it for synthetic division? We have a polynomial on top, we have a binomial on the bottom, and the degree of this binomial is 1. And let's just keep in mind what our answer was over here. Okay? See, 3x minus 4 plus 3 over x plus 2. That was our answer, right? Okay, so let's do synthetic division on this. I'm going to grab it real quick and copy it. And then go back over here. Oh, that didn't like that. There we go. Okay. So here's the way synthetic division is going to work. Everyone have that written down? We are going to make sure that everything is in descending order first, which we do have, right? The top is descending order, 3x squared plus 2x minus 5. Descending order meant highest power down. The bottom is also in descending order. What we're going to focus all of our attention on are the coefficients. We have a 3. Remember, coefficients are the numbers in front of the terms, right? And then we have a 2, and then we have a negative 5. So we have 3 coefficients in the numerator, correct? On the side, this is where we start the synthetic division. You're going to draw an upside down division box. Okay? And then you're going to write those 3 numbers that we just had with a little bit of space between them. And don't write them down yet. Just watch me for a second. 3, 2, negative 5. Notice that I left space underneath them, okay? That's what you want to have there. You want to go ahead and write that down. You have the division box upside down, 3, 2, negative 5, with at least enough space to write something underneath these numbers. Now, what we're going to do is look at the denominator and notice that next to the x, there's always going to be some number, right? Because that's the only way we can do synthetic division is if there's a number sitting next to x. We're going to take that number and we are going to place it here, but, this is the big but, we are going to change its sign, right? So it's a positive 2. We are going to place a negative 2 here. Change the sign. So what if it had been negative? What if it was x minus 2 down there? You'd put a positive 2 there, right? Okay, that's the setup for synthetic division. That's what will get us started, all right? So now what I'd like to do is I'd like to start the synthetic division. I'm going to start by looking at the first number, which is a 3, right? And I'm going to just drop that 3 straight down and put it right here. Whatever that first number is will always drop down and become this, go right underneath the division box. Always, right? That number always just drops. Then I'm going to take the number out front, which was negative 2, right? I'm going to multiply it times the 3. So I'm going to put a little old school multiplication symbol there, right? Negative 2 times 3. What's negative 2 times 3? Negative 6. That negative 6 is going to be placed right here underneath the 2 in the next column. And then I will add down again. So I will come down, and this time I'm adding here, so plus. So what is 2 plus negative 6? That's the same as 2 minus 6, isn't it? I'm not multiplying, I'm adding. So this gives me a negative 4. I put that right here. Then I repeat the process again, okay? I go to the negative 2 out front. I multiply it times the negative 4. I move that number up underneath the negative 5. So what is negative 2 times negative 4? Positive 8. Okay, that positive 8 is going to go underneath this negative 5. Now we will add straight down. When you add that together, what's negative 5 plus 8? You get 3. And once we get to that last one, we are done. Okay? We are done. Now, that doesn't look like the answer, does it? No. But if you go back and look at the answer, what we had was 3, right? 3x. Then we had minus 4, right? And then we had plus what? The 3 over our x plus 2, right? Notice the 3, the negative 4, and the 3 are also what we have here. The 3, the negative 4, and the 3. Do you see that? So what we do is we somehow have to extrapolate the answer from this. So here's how the answer is going to come out. First thing I'll point out is this last number here, we like to put a little kind of half box around it here, or like a little L shape. This will always be the remainder. Okay, that is always your remainder. That's how much is left over. And if you go back and you look at that long division that we did last class, that was our remainder, right? 3. Now the first two numbers here, this needs to turn into a 3x minus 4, right? Because the answer had 3x minus 4. So the way we're going to determine that there should be an x next to this is as follows. We go to the original problem. We look at the degree that we had on the numerator. What was the degree up here? On the top, it was 2. Your answer, this 3, needs to have an x next to it, and the power on that x needs to be 1 less than whatever the power up here was. Always. So since this is a 2, the power on this x needs to be a 1, and so we don't write anything, we just write x. What if this had been a 4? This would be x cubed. If this was a 7, this would be x to the 6th. All right? And then the rest of the numbers, which in this case there's only 1, the powers on the x just keep coming down. So what's the next power below x? Nothing. No x's, right? So that's why I just put minus 4 here. And then how do we use the remainder? Well, from last class we said you don't write R3, right? We don't do that anymore. What I said is you always put plus, right? Then you put your remainder, which is 3, over your what? Divisor, whatever you're dividing by. What were we dividing by? X plus 2. And we're done. Now, I realize that that may initially seem like that took longer, and it might be more confusing, but trust me, once you get down this whole thing down with bring that 3 down, multiply, put that number here, add down, multiply again, put that here, add down, get that all, and once you get quick with it, then you'll prefer this over the long division, trust me. All right? Okay, another example. Let's try, let's try 5y squared minus 4y plus 2y cubed minus 5 over or divided by y plus 3. All right, can we use synthetic division here? Yes, because the bottom is a variable, right? Now I'm using y instead of x. Is that all right with everyone? I have a number next to it, plus 3. So I'm allowed to use synthetic division. So let me start by putting my box, an upside down box here, or upside down division symbol. What will go in the box? The coefficients. In descending order. See, I was trying to trick you. I couldn't do it. Sorry. I tried. You have to have it in descending order. The original problem was not in descending order, was it? So you have a y cubed here. So I need to go back up here and I need to kind of look at this and go, I mean, maybe you don't need to write it down, but I will. In descending order, it's 2y cubed plus 5y squared minus 4y minus 5. So that's in descending order. Then my coefficients are 2, 5, negative 4, negative 5. So I'm going to go ahead and put those in the box that way. Y'all see if you do it the other way, it's going to be completely wrong, right? You have to have that in descending order. So 2, 5, negative 4, negative 5. Now what? Put something on the outside. What do we put on the outside? Negative 3. Negative 3, because I take that, it was a positive 3. I change a sign. Ooh. Have y'all ever seen that symbol before? That little triangle, have y'all ever seen that before, used in math? Just so you know, this means change. So this symbol is called delta, but we use it to represent change. You may have seen it when we were back in another class when you were talking about slopes of lines and you said like change in x, change in y, they may have used that symbol. So we're just going to change the sign, all right? You ready? Here we go. Start with the 2, drop it straight down. Then multiply negative 3 times 2. That gives me negative 6. I drop that answer right here. Negative 6. I add down. What's 5 plus negative 6? Negative 1. So I'm going to have a negative 1 out here. Repeat the process, right? Negative 3 times negative 1 is positive 3, right? Add down again. What do you get? -1. Repeat the process. Multiply, that's 3. Add down, -2. That's my remainder, all right? That's my remainder. Now, I need to interpret this answer. So what do I look at right now? The degree of the numerator, way up there in the top left corner, right? Up here, it was 3, right? So my answer needs to start where? At squared, right? 1 less than this. And the variable I'm using here is what? Y. So this 2 needs to have a y squared next to it. So I'm writing the answer now. 2y squared. Does everyone understand that 2 comes from here? Then what? I have a -1. Am I going to have a y next to it? Yes, because remember, once you get to here, the powers just start coming down. So I have -1y. Could I just put -y? Okay, and now I have another -1. So I put that here. Do I have a y next to it? No. So just -1. Do I have a remainder? Yes, plus -2 over y plus 3. There it is. What do you think? I mean, once you get it down, the only thing you have to be careful with is just making sure all your multiplications are correct. You know, your signs, because like if you just come down here and you go, okay, -3 times -1, you accidentally put -3, it's, you know, everything's gone after that. So you want to be quick, but you want to be careful. Okay, let's look at something else. Can we use synthetic division here? Yes, right? Good. So I can use synthetic division because the bottom is a binomial, degree of it is 1. I have a number next to the x. So let me start my synthetic division. I put my coefficients. Now, it's already been pointed out that we have an issue here we have to deal with. And that's the fact that I don't have any x cubes, do I? I have x to the 4th. I don't have an x cubed. I don't have an x squared. I don't have an x, but I have a negative 16. Remember in long division, we said when we skipped a variable, when the variable wasn't there, like an x squared or something, we always accounted for it in our long division so we could have spaces. In synthetic division, you must also account for those. So what do you think you're going to put there? Zeros. So really, I mean, again, you don't have to write this, but this really is x to the 4th plus 0x cubed plus 0x squared plus 0x minus 16, isn't it? That's what it is in descending order. So the coefficients are actually what? What are those coefficients? A 1 in front of the x to the 4th, right? There's really a 1 there. And then a 0, and then a 0, and then a 0, and then your negative 16. That's what needs to go in that division box. 1, 0, 0, 0, negative 16. What goes on the outside of this division? Positive 2, right? It was negative 2, I put positive 2. All right, you do this one on your own, see if you can get the same result that I get. Anybody need help with that? What is the power going to start with here? X cubed, right? Because the initial problem up here was x to the fourth. So this is going to start with x cubed. Now I have a 1 in front of that, so I could put 1x cubed. I don't have to have the 1, but I'll put it 1x cubed. The next number I have is a positive 2, right? So I put plus 2x squared, then plus 4x, so the powers keep coming down, plus 8, and then I have a remainder of 0, right? Which means I don't have to put anything. So I'm done. I don't remember did I put, oh I did, okay. What do y'all think? Uh-oh. Hold on just a second. I forgot to turn the recording back on, so I want to make sure that I get this recorded, that this is the review for the final. So all right, that should be enough. Do that for Wednesday next week.